So moving on to the remaining SIG updates, I want to start with the models and tutorial SIG for 2024. In the last year, we had refreshed the Onyx model zoo. We'd opened, we'd added a new front end to the GitHub LFS repository we had. It's under onyx.ai/models, where you can go to download models directly in Onyx files and search, filter with different filters across offsets, authors, and tasks. And we also open sourced Turnkey ML under the Onyx repository, an AI insights toolchain that automates export analysis of models from PyTorch all the way to Onyx. And this was the toolchain that was used to populate the Onyx model zoo as well. I'll call upon a couple of my colleagues to go over some of the refreshes that happened.
Hey, I'm Jeremy. I'm representing the Turnkey ML maintainers. So yeah, we released Turnkey in December of last year. We used it to totally refresh the Onyx model zoo. And the idea of it is it's a no-code solution for Onyx export and compilation. So you can just kind of like point it at a script that already has some PyTorch model working in it, and it'll go in, profile the script, pull the model out of it, turn it into Onyx for you, and then can pass it into subsequent like optimizers or compilers. And so that made it really easy to refresh the Onyx model zoo because we could go discover like thousands of PyTorch models and turn them into Onyx models. This is also getting heavily used within AMD for the AI PC program. So we're doing like many thousands of compiles per month as we like make sure all this stuff works on the AI PCs. And we even built a cloud service around it. You're doing so many compiles all the time. We wanted to start doing them in parallel and get a ton of them done per day. A big turning point for Turnkey ML since release has been our investigation into generative AI. So that was one of the kind of noteworthy things not totally covered in the initial release of Turnkey ML. And we realized that our code base needed more kind of agility and flexibility in it to handle generative AI, which is often not so simple as just kind of calling a forward function out of a Onyx model. And so, we want this kind of no code, high level of automation, but then having like one automation that's supposed to like handle every scenario of generative AI is kind of difficult. And so what we're working on right now that ought to come out in Q3 of this year is a refresh of the underlying architecture of Turnkey ML that makes it much more flexible in terms of what plugins are able to do and what types of models can be supported through this high level of automation. And so, you can look forward to that coming out before too long. This is just a bit of a teaser for it. If you're like a heavy user of Turnkey ML, I'd love to hear from you. Like, please come talk to me during the happy hour or reach out to me anytime. And yeah, if you're a user, there's quite a bit of changes coming in terms of making things more flexible. And so, yeah, hit me up for a demo or to hear more about it. But that's it. I'll just give the quick teaser here. Thanks.
All right. Hello, everyone. My name is Philip. I am a colleague of both Krishna's and Jeremy's. I'm here to present a tool called Digest AI. I'm excited to present this. This is a very new tool that the team has been working on. My primary function on the team is to do model analysis and model enablement. So there's various reasons why we needed to build this tool. What we're trying to accomplish is gleaning model insights from right now Onyx files in order to make informed decisions on what to do on the other end. And so you can imagine some use cases might be that model owners that are running their models in production may not want to share their models. And how do we then make informed decisions or provide them with state of the model through a particular tool chain? So what we can do is, instead of asking for them to share anything proprietary, we can give them a tool that enables them to extract the relevant information that we need to do our job. And so I'd like to give you a quick demo of the various analytics that this tool is designed to do. And then we'll All right, so the first thing that we can do here is we're going to be looking at these three buttons. Essentially, they're all about loading in Onyx models. So the first one is just if you want to simply open in a single file. And so I kind of have some models already preloaded on my system here. So we'll take this clip text model and open it. And what's going to happen is Digest is going to start loading the model. It's going to be doing some analysis and grabbing all the insights that we need. And then it's going to be placing it all into this GUI so that we can have some information in order to save off into reports. So right away, you can see that we get all the information that you'd expect out of a model proto from Onyx, like the offset number, how many nodes are in the model, the parameter count, and then the flops counts. And the flops count here is the algorithmic number of floating point operations that you have to do in order to run a set of inputs through your model. So the first thing that we can see below these sort of cards on the top is that we have an op histogram. So this comes in handy if we just want to understand what are the top ops that are found inside this model. And so you can go through and understand what the heavy hitters are. To the right of that, you have the parameter intensity per op type. So you can see, given a model of some size, how many of those parameters are being used as map mols versus convs versus, say, a gather here for an embedding layer. As we scroll down, we have some more data that we can look at. We have a very similar pie chart for the flops intensity per op type. So this tells you how many flops you would have to run for a given op type, so you can focus on which ops you may want to support more. I'll click on this graph here. This is the model similarity heat map. So this is very interesting. We have use cases where, again, a particular owner of a production model may not want to share their model, but maybe they can run their model on this tool and then tell us what models in the open source community theirs most represents. So this is a likeness graph, and you can see that we have the clip text model is what I took as input, and what we can see along the y-axis going down are all the models that it closely resembles. So you can see Stable Diffusion v14 text encoder, so we know that Stable Diffusion in many cases uses clip as the encoder. Scrolling down a bit further, we get the insights into just the inputs and outputs of the model. So this is all fairly standard types of analysis that you might do. The next I'll actually just mention too, we have a nodes list. And so this is essentially just a row by row node analysis of each of that's found in the Onyx graph. We show you the node name, the type, the parameters, flops, the shapes of it, and any attributes that are attached to it as well. We can also group by shape counts. And this is actually pretty interesting because if you have a compiler that you're trying to support various ops on and you want to know in a particular model how many convolutions of a particular shape exist most frequently, you may want to start looking at those ops before ones that only occur, say, once, for example. All of this you can save to CSVs, by the way. So if you ever need to do any further processing, we can save each report just by going here, selecting a folder, and it'll save all of this information into a text-based report. It will also save it into a series of CSVs and also PNGs for the images. Moving on, we have also a multi-model selection. So this gets pretty interesting because in many cases, if you have production models, you don't just have one, you have many. And you may want to see what the differences are between those. And you can report in a similar fashion the differences without actually, again, giving any of the secret sauce or proprietary information. So one of the things that we did was we started analyzing what are the different versions of UNets that we have in different Stable Diffusions. So what I just did was I selected a folder that had 4 versions of it, 1.5, 2.1, XDL, and XDL Turbo, and it loaded it on the left pane here. If there were any duplicates, so we'll have cases where production models maybe have like small variances, and we don't really care so much about those because we just really need one unique variation of a particular category. So if there are any similar models, they'll show up in the right-hand pane. These didn't have any, so it's blank. If I click Open Analysis, now we're stepping through each individual model, doing the same kind of analysis we did on the previous page. And now what we have is sort of a more global view of the differences between these models. So you have things like the name, the offset, the total nodes, the parameters, the flops. You have a combined op histogram. So this gives you just like a nice overview of how many per op there are across all 4 models in this case. And then further, we have a stacked op histogram. So the interesting thing that we can glean from here is that we wanted to understand what are the differences between the 1.5, 2.1 versus the XL ones. And so what we can see is the op histograms for 1.5 and 2.1 kind of have the very same histogram distribution, right? You can see that the ads kind of track similarly. You have a lot of the same slope on some of these bars. And similarly for the XDL versions, you can see that those track closely. So you can imagine, given a series of models, you can now start getting some really nice high-level information across all four in this case. And again, you can save these reports off into various CSVs and PNGs. Lastly, I wanted to share the third way. Now, this is, we still call it beta, but we added a Hugging Face feature such that you don't even have to leave the app and you can really just do a search. We'll do like a Resident 18 in this case. Yeah, I'm on Wi-Fi. So it scrapes through the Hugging Face website, specifically looking for Onyx models, and then it comes across a series of them, lists them here. We can select one, and then we can click Open Onyx. What it'll do is download the model straight from Hugging Face. It'll load it into the model summary, and then give us the same readout that we saw on the previous page. So it's pretty fast just to get some fast insights about your model. And then just note as well that every time you open up a new model, it's as a tab. And so you can go back to other models you've already opened and do a compare and contrast really efficiently. The last feature that I want to share before wrapping up is this freeze function. So one of the things I hit a lot is that I want to freeze my models. And what I mean is I want to run shape inference on a known set of input shapes. A lot of times Onyx models will come with dynamic shapes, and a lot of compilers may not support that. And so you end up finding yourself writing a custom script or having some known numbers that you just want to plug through. So what we did was we offered this little freeze button. So when we click this, it will open up a new page. You can save the new Onyx file that's about to be created into a specific directory, or you can use the default cache directory that we're using. And then you'll notice here, there are 4 input forms here. So we have batch size, and you can always correlate that down into the input tensors on the bottom. You can see which tensors use which dynamic shapes. So we'll have batch size 1, I think 3 and 224 for the batch known channels. Height and width is pretty standard. We'll click Apply Shapes. This is adding those shapes to the Onyx protobuf. It's then rerunning the analysis on the newly created protobuf, and then opening it up in that model summary view. And now we have the flops count because you need the shapes to be static in order to calculate the flops. And we get all the same analysis here. We can see that the similarity tool is yelling at us saying it's resonant, it's resonant. So, so it all works well. And with that, thank you for checking it out. And I was happy to demo this initial version of Digest to you. Yeah.
It's an awesome tool, right?
Oh, thank you.
Is it doing static analysis or is it doing some runtime compiling too?
Yeah, so right now it's all just static. There is no runtime component as of yet. If I may speculate a little bit, some of the tools that Jeremy just mentioned as well kind of go hand in hand with this tool. And so it may be something that we see in the future.
And okay. I guess it doesn't matter whether it's CPU or GPU then, right? Because it's just
Correct. Yeah, right now everything's been written to be kind of hardware agnostic, and it's really doing analysis at the model level. Yeah.
awesome. Thank you. Is it available for download?
So the team is working on a deployment strategy right now. We would love to open source this. So definitely keep in touch, and yeah, we'll definitely stay on track.
Thanks.
This tool supports multi-model input.
Multimodal?
Yeah, I have
Model?
input from LiDAR, input from image sensor, and I end up having 5 to 60 input.
Oh, I see. Are they all individual files?
They're different input, or you can combine them into one single input.
Okay, interesting.
For the input is typically for the imaging or
Mhm.
that type, but there's other type that you have input from various different sources.
Okay, so right now we're only inputting like a single Onyx model and doing analysis on that. Maybe we can sync up afterwards and see what that idea is in more detail. But right now it's just like a single Onyx model that's already been with a known number of inputs. You can load multiple models in the model similarity way, or have them on different tabs if you needed to do some fast analysis.
Thank you.
Yeah.
So the idea is like your client would run this on their own model and then send you the report.
Yes.
Does that work well in practice?
Yeah, so we're actually, this is our V1, and so we're just now getting ramped up and getting the feedback on it. But yeah, so in many cases, when we're trying to even internally, share data amongst different groups, it has shown to be it does work. Yeah.
If you consider making it a web app, what's the benefit of, looks like this is a native application?
Yeah, good question. We did consider a web app. We went with this format because a lot of times if you're going to be sharing models or you don't want to share models, uploading it to a web server is there's some concern for privacy there. There's also a lot of time to load the model through the interweb. If you have it locally, you can just...
You can have a JS application that runs in your browser.
You could, correct, yeah. Yeah.
If you're just having the ops and you also list their shapes, like what would the difference be between somebody giving you an honest model without the parameters versus seeing all the ops and their shapes and just not knowing the order? Or is it up to the user to decide how much of that report they're willing to share?
Yeah, it's a good question. It varies per owner of the model, right? So some don't want to divulge close to anything, while others maybe, yeah, you can just clean the parameters, and sometimes that works, and you just create like a proxy, for example. But you kind of see it all, along this whole spectrum of anything from nothing to almost everything. Yeah. Thank you again.